Alright team, let's talk standard optional in C++. Have you ever been in a situation where you have a function whose job is to create an object based on some input, right? If the input satisfies the needs, then the object is made and returned from the function. But if not, then what, right? You end up returning some kind of a dummy value, right? Let's look at an example here to understand more of what I'm talking about, right? I created a really simple object here called pizza factory, right? I hope everybody likes pizza, right? And this pizza factory, its job is to create pizza, right? It's to create pizza objects, right? We have two types. We have a cheese pizza, we have a pepperoni pizza, right? And this function here takes in the type as a string. So if your type is cheese, you make a cheese object and return it. If your type is pepperoni, you make a pepperoni object. It's a raw pointer, right? So you use new and make a pepperoni object and return it. But if it's not a cheese or a pepperoni pizza, then you end up returning a null pointer, right? To satisfy the return type of this function, which is a pizza pointer, right? And just to quickly look at the classes, I have a interface here called pizza. It exposes a pure virtual function, bake, and then we have two classes, right? Cheese and pepperoni that inherit from the pizza base class, and all they do is they have a simple function called bake, and if you invoke the functions on them, they're going to say, for the cheese they're going to say okay, baking cheese pizza, and for pepperoni they're going to say baking pepperoni pizza, right? That's not really important here, but just so that you guys understand what the classes are made up of. Okay, so now let's create some objects here, right? First let's create the pizza factory, right? Let's call it pf, and let's uh, create a pizza, right? Let's say we want to create a cheese pizza. So let's do cheese pizza, cheese, and this thing returns a raw pointer, so we can store it in a raw pointer. Let's call it p, and let's bake this pizza, right? So let's call bake on it. So if we run this program, hopefully we should see baking cheese pizza, right? Because that's what the bake function is supposed to do. It's just couts to output saying baking cheese pizza, right? Okay, now let's say instead of cheese we pass in an empty string here, right? What's going to happen, right? Let's run this. The program is obviously going to crash, right? Because empty empty type is not really supported, and it's going to return a null pointer, correct? And if you try to access a null pointer here on line 50, your program is going to give you some weird undefined behavior. It's going to crash, right? We can obviously add some protection here and make sure that if it's not a null pointer, only then call bake on it. But the question in my mind really here is there a better way to deal with this entire situation, right? Can we make this return type more safer? Rather than returning a null pointer, can we make this function more safe and more clearer, right? And this is where standard optional comes into picture. In C++17, you can use a function called standard optional, right? It's basically a templated class that can either have a value or it cannot have a value. It's basically a wrapper around a value, right? So let's see it in action. So instead of returning a raw pointer here, what I can do is I can return a standard optional, right? Of the same thing. That's the pizza raw pointer, right? And instead of returning a null pointer, if you want to return an empty value for standard optional, you return a standard null opt, right? Now the intent here is more clear, correct? Because you can say that okay, if my type is cheese, I'm returning a cheese object. If my type is pepperoni, I'm returning a pepperoni object. And if my type is not supported, I return something that's just empty, right? It's not there. It's a standard optional. Okay, let's change some code here to actually deal with the standard optional, right? So now the return type here becomes a standard optional of the pizza raw pointer. right? And with standard optionals, what you can do is you can really check if the thing has a value in it or not, right? So you can do something like this: if pizza has value, only then call bake on it, right? But you can't directly call bake on it because p is of type standard optional, so you have to actually get the underlying value from it, right? So you can use they expose a function called value, so you can use dot value, and then the underlying value is obviously a pizza raw pointer, so you can use the arrow sign and call bake on it. So let's run this. Hopefully we should see some good behavior now. Yes, correct, because right now we are giving it a empty thing, so it says the program did not output anything. But let's change this to, let's say, pepperoni, right? So pepperoni. Let's run this. Baking pepperoni pizza, right? Alright guys, so hopefully the use case for standard optional is slightly more clear now. As always, feel free to play around with it. And if think about standard optional, think of them as like a more safer and clearer alternative to indicate like a no value situation, right? It definitely promotes a clear intent. Like with this function, right? If its return type is standard optional, there is a chance that you're going to get the real thing, the real object that this class is supposed to create, or you're going to get nothing, right? So the intent is clear, right? The code becomes more readable, and you understand it better, and it also promotes like more safer behavior, right? In this example, we saw that, hey, accessing a null pointer is crazy, right? It causes your program to crash, but you can use standard optional and totally avoid that behavior, correct? So hopefully guys you liked this video, and if you did like it, please press the like button, and don't forget to leave your thoughts and feedback in the comment section, right? See you next time. Thank you very much.